Assalamu alaikum. My name is Walid Sultan Arif. I am a student of Mechatronics Engineering. As my field explains itself about the video I am going to present. Basically, it is our semester project. There are two reasons for uploading it on YouTube. One is Sir Umar wants it, and the other is that it might help anyone who need to simulate sensors like voltage sensor, current sensors, SD card sensor, RTC, and ultrasonic sensor. I am going to elaborate my video into four parts. In first part, I will explain about our project. In second, I will explain you about components that are used in it. In third part, I will explain about the datasheets of the sensors, and in the last part, I will elaborate about simulations of the sensor and the codes of Arduino. My project is to make an obstacle detector car, a car which can help people with disabilities to drive a car. For example, the car will stop when some persons come near to it. We are going to use different sensors. Among them, the most important sensor is an ultrasonic sensor. I am going to show a small video and elaborate it. Basically, it is about an ultrasonic sensor. Ultrasonic sensors helps to reduce the blind spots. Basically, they help to detect any moving or static objects that come in its surrounding area. It can detect pedestrians, cyclists, cars, and etc. And they provide a visual and audible warning. Different sounds are produced depending on how dangerous or how close the object might be, which helps in reducing accidents. As you can see, basically our project looks like this. The ultrasonic sensor detects first the wall, then it detects the door and stops automatically. This is the second part of my video in which I will tell you the components that have been used, the objective of my project, and etc. And we three students have been assigned to do this project. I along with Akib and Abdullah made this project. This is a circuit diagram of our project in which an ultrasonic sensor Arduino and DC motors are displayed. Components that are used are ultrasonic sensor, color sensor, encoder, IR sensor, voltage sensor, current sensor, Bluetooth device are a board base that we actually made in our previous semester, and Arduino, a motor controller, a battery, and some tires. These are some of the details of ultrasonic sensors. I will one by one show you all the details of all these components. You can stop the video at any time to read and get whatever you need. And basically, our objectives of this project is that the board will follow a line using an IR sensor, and it will stop at red light and will go on at green light, which uh, for uh, For this purpose, we have used a color sensor. An ultrasonic sensor is used to detect an obstacle within some specific distance, and a Bluetooth device is used. The purpose of the Bluetooth device is to control it remotely. In this part of the video, I am going to explain the data sheets of different sensors. In my project, I have used ultrasonic sensor, a current, a voltage, and a touch sensor. I will show you some of the details one by one. First, I will tell you about ultrasonic sensor, which we can call it in market as HCSR04. Basically, what it do is it can detect. Its range is from 2 centimeter to 400 centimeter, or you can say 4 meter. It works on its working frequency is 40 Hz. Working voltage is 5 volt DC supply current, and working current is 15 milliamp. Its measuring angle is 15 degree. This is the figure of ultrasonic sensor. It has 4 pins. One is VCC, which is used for input voltage, and the second pin is trigger input signal. The third pin you can see is echo input signal, and fourth one is grounded. This is a timing diagram of ultrasonic sensor. Now I will tell you about the next sensor, which is a current sensor, AC S712. I have chosen this sensor because it has many features. Basic features are it has low noise analog signal path. Its output error is very less as compared to the other sensors. It has a zero magnetic hysteresis nearly. It has extremely stable output offset voltage. It is also factory trimmed for accuracy. This package comes with 8 pin. And this is the circuit diagram. The 8th pin is output 5 volt, input 5 volt VCC voltage, and the 5th pin is grounded. These are the ratings of this sensor. Supply voltage. It means that at 8 volt VCC. It works at 5 volt. This is the circuit diagram, functional block diagram. Now I will tell you about the its electrical characteristics. Its supply voltage is minimum. It works from 4.5 volt to 5.5 volt. Its input current ranges from 6 to 1.1 milliamp. Hysteresis current, as I have told you earlier. Now come the third sensor, RTC, real time clock. It is actually used to display the time and date, which can be pre-adjusted, or you can adjust according to your own desire. It is a low power consumption sensor. I will show you some of the details of it, like its circuit diagram. Its pin configuration is this one. It has 20 pins. This is the operating circuit. These are the certain parameters of it. Supply voltage VCC, which means at it will work at 2.3 volt to 5.5 max. Its electrical characteristics are shown as below. Now the fourth sensor, which is basically whose simulation I will explain in this video later. This is a touch sensor. You can say when we touch it, the all the system will start working. Its operating voltage is 2 volt to 5.5 volt, just like all the previous sensors. Its response time max is 60 millisecond at fast mode and 220 millisecond at low power mode. Its sensitivity can be adjusted by the capacitance from outside. This is the circuit block diagram of in this touch sensor. These are the pad descriptions of this sensor. Electrical characteristics, DC and AC characteristics of touch sensor. And this is how we can display, we can adjust its sensitivity. You can see from this figure. That's all from for the data sheets. In the next part I will tell you about the simulations and the codes of Arduino. Now in the last part of the video I will tell you about the codes and the simulation. Firstly I will explain you about the code of the touch sensor. Touch sensor is connected to the 9th pin of Arduino. We have taken a variable called LED, which is connected at 8th pin. Firstly, we begin with a command of virtual screen. Serial begin is the command for the virtual screen. We have taken from serial begin, virtual screen will be activated. From LED we will take output, and from sensor we will take input. We are using a loop function here. Now we are using if-else statement. If we test, it will show high, vice versa, it will show low. In the end we printed serial print function with this command. Delay function is used in a way that it will show readings after 500 milliseconds. Now I will explain the code of the voltage sensor. The same command serial begin, which is used to activate the virtual screen, we have used a loop function here. A variable we have made which was whose name is sensor value. This potentiometer is connected at A0 pin. The formula that will convert the analog value to digital value is this one. In the end we have printed the voltage as a digital on digital screen through this command. Now I will tell you about the current sensor. First we made all the variables like current pin sensitive. We have made first I will explain the variables. The current sensor is connected at A3 pin of the Arduino. Its sensitivity is set to 66. These variables will be used in loop function. Offset voltage is set to 2.5 volt. With this function we have activated the virtual screen. Now we are using a loop function. We are reading current value. For that purpose we have to convert it from analog to digital value. And this is the formula for conversion of analog to digital. Now if we need to find out the exact current value, we have to subtract the digital voltage from, from the offset voltage and divide it with the sensitivity. Now we have printed that current value. There is a delay function that is used in the end. Now comes the turn of RTC sensor. This is the last code I am going to explain. First we access all the libraries of this sensor, like using liquidcrystal.h, wire.h. We have then declared the pin that we will use. There are two inputs, this at 8 pin and 9 pin. One button is counter button and the other one is the reset button, through which we can change or reset the date or calendar time. We converted these into binary. We converted these from binary to decimal. This conversion is done here. Then we displayed the time and the calendar, means date. Then we have used a void blinker function, just like this blinker that is blinking on the screen, same will be displayed on the LCD. We then displayed the dates and time. We pointed the date and time. In the end we pointed date and the time. Here this right wire function is used to read the date and time. Now I will tell you about the simulation in coming video. Now I am going to run the simulation. First I will compile the Arduino code. I will explain some of the sensors. This one here is a touch sensor. This is the output, a ground and a input voltage. This is an LED which is connected to Arduino, whose one end is grounded. There is our voltage sensor. A potentiometer is connected here. This is our current sensor here, and this is RTC sensor. This is the virtual terminal screen, and here comes the LCD. I have connected the 7th pin of Arduino to these 7th pin of LCD, likewise the 6th pin with D6, and so on. When I will press this button, current will be displayed. My compiler has done the compiling. Now I have to Now I will start the simulation. This is the virtual terminal that I have been telling you about. It is showing a voltage 4.15 and it is telling that light is off and the current is 0. Its voltage will change when I drag this potentiometer somewhere. Look, the voltage here dropped to 3.91 when I will show you the maximum voltage. At 100% it is 5 volt, and at 0%, at 50 and at 0 I will show what's the value of the voltage. At 50 it comes out to 2.5 and at 0 it will be 0 volt. I will make it 100%, then I will tell you about the current. The LED will turn on when I press this button, and the current value will change. My CPU load has been increased, that's why it's not running a proper smooth simulation. That here is an LCD. I will run again the simulation as my CPU load has been increased and it isn't working smoothly. This screen is displaying the time and the other one is displaying the date. Look, I can increase the time by just pressing the counter. I will change it to next. Now the date. Today is 26. It will take long to change it, so I will just stop here. But by pressing these buttons, it's where it changes. That's all of the project that I can explain to you guys. If you have any further queries, do mention it in your comment or in the Google forms that I will share the link of that.